Hello everyone. So we're just going to go over a couple of the slides from our second speaker at the IDC conference. So I'm going to share my screen and go over it. So here we have Dr. Furot Dawood. He spoke about a case study on a standalone hybrid PV hydrogen power system for homeland communities in regional Western Australia. Now, one of the discussion pieces that was apparent during the presentation was the application of hydrogen and how we can see the actual benefits of it. So to give a bit of an overall project, or like what the project, the case study was designed around, was the application of the utilisation of hydrogen. So currently within this remote community within the Pilbara region, which is roughly here, they have 3 diesel generators, 110 kVA, I think they are, off memory, and they typically deal with around like 1.5 megawatts an hour per day scenario. So that's the kind of loading that they require. So the case study was, okay, if we look at how renewables can offset and what system is going to provide the most reliable and feasible use of both the area, its location, without having to draw upon resources, whether that be importing water for use within the electrolyzer, or importing of fuel, or importing of services, because the system's going to be overtly technical and require skilled personnel on site. So there were a lot of different factors that the team had reviewed, and they'd come up with a system. So basically from the aquifer, that would go into a desalination plant that would also accommodate for the water storage. Then that would go into an electrolyzer with a fuel cell arrangement. You would also have the PV array on there as well. And then that would go into your inverter. Then that would go out to your grid, so to speak. So here it is during sunshine. We can see here the PV array. We can see the desal plant pulling water from the aquifer, going through the water storage into the town supply. But that water is also going through, going into the electrolyzer after it's gone through its purification. The electrolyzer then goes into a small hydrogen store that then feeds into a fuel cell, and then that goes into the microgrid to assist with the small community that they have there. That also is fed from the PV array into the battery as well. Then you've got compensation of loading from the diesel generator at load demands if required. So that's what the system looks like. And then when the sun's down, obviously the PV is not going to work. You're going to pull from the fuel cell and from the battery as your primary production, or your primary mode of electrification. Those were basically the simulators. But here, this is what I want to get to here. This was the actual model feasibility spreadsheet. I know that we love spreadsheets, everyone does. But this gives us a good indication of what application hydrogen has in a real use scenario. So here in the base case, we can see here that there's 3 diesel generators, obviously, with a 110 kV kilowatt each. That also then allocates the generator working hours of 8,082. That then, we're looking at the present cost of being 7.7 million. The operating cost is 593,000. The majority of that's due to diesel. So the cartage and haulage and all of the prices around diesel. So they're looking at spending around 340,000 per year just in diesel. Then for that base case to continue operation, there was $30,000 of initial capital that was going to be allocated for the project. That would be to deal with probably modernisation of the diesel fuel rail systems, probably the exhaust systems as well, to get them to a better, like probably a Euro 4 or a Euro 5 standard, probably also the injection system. Wasn't really clear about what the initial capital was, but it's probably modernisation of the diesel systems. So you're looking at a cost of energy, COE, of $1.18. Now, if we look at option 1 and option 2, the difference is with option 1, there's no diesel generator at all for compensation. So to compensate the load or compensate the technologies, they removed it to see what the cost would be. So they're completely reliant upon renewables here. And the argument for it was just to do it from a modelling scenario. But what you have here, you have a scenario where obviously your PV array stays the same, but your battery capacity increases to compensate for the loss of 3 diesel generators. Your electrolyzer capacity also increases by a portion of, like 30-odd%. And also your tank capacity increases by a magnitude of 30-odd%. So what that means is you've got your initial investment to deal with that is $3,700,000, and then your operating cost per year is $168,000. So then your cost of energy comes to about 90 cents. So that's without the diesel generator, and obviously here you don't have any cost of fuel. Now, if we look at a pure hybrid mixture, you're looking at the removal of 2 diesel generators. You're not having to rely so heavily on a larger battery capacity. Your electrolyzer capacity is also adjusted to have that compensation. But here, the funny thing is, this is probably your cheapest modality. What I mean by that is, like, out of all of those options, your cost of energy is your cheapest. And considering that there's only an annualized bill of $7,000 for diesel, this is probably the best indication of how hydrogen will be used in the future. So when we talk about decarbonisation, we talk about the application of hydrogen. The industry is still, like, from a curve perspective, we're still on that early adopter innovative cycle at the moment. But this is a good indication about a mature program of how hydrogen can be implemented within projects. So it's not seen as, the magic pill that everyone thought it would be, but it's seen as a percentage. It's seen as, okay, well, what are we going to do? How are we going to get that figure of net zero? Are we going to be fully reliant upon total renewables, or is it playing a part of a bigger picture? And that's where I believe it is. Should we have full renewables? No. The reason being is our technology is not there. There still needs to be either a heavy reliance on, if we do go to renewables, there's a heavy reliance upon battery capacity, and then batteries have have an expected life cycle. We have degradation of cell. We have thermal runoff that we have to deal with that. But if we have a model where we're removing our reliance upon fossil fuels, but we're also building on that infrastructure and going, okay, we're going to remove the majority of it. We're going to have it there so it's at backup, so our system doesn't go black. And while that's happening, we can then introduce things like, we can introduce better technology with hydrogen, we can introduce PV arrays, and we can have like this hybrid blended system. So that was the biggest takeaway for me, and it's showing us clearly by the numbers where the industry's headed. So I hope you found this interesting. Like to know everyone's thoughts about this, and I'll see you guys soon. Bye.